Today, we're going to meet a chemical character that is, believe it or not, quietly shaping almost every aspect of your life. We're talking about everything from the food you eat to the clothes you wear. This molecule has a fascinating story, so let's dive right in.
So think about this for a second. Vinegar, butter, and nylon. What could those three possibly have in common? I mean, they seem totally unrelated, right? You've got a condiment, a food, and a fabric. But they all share a hidden connection, a kind of molecular architect working behind the scenes.
And the answer is carboxylic acids. Yep, this one single family of molecules is responsible for all of it. They're kind of the unsung heroes of the chemical world, busy at work in so many of the things we taste, smell, and use every single day without even realizing it.
Okay, so to really get to know these molecules, we first need to understand their identity. What exactly makes a carboxylic acid a carboxylic acid? What makes it tick?
Well, the secret is all in this one little arrangement of atoms. It's called the carboxyl group. You can think of it as the molecule's face. If you see this COOH group, you know for sure you are looking at a carboxylic acid. It's like their unique signature.
And you know, the name itself is kind of like a recipe. Carboxyl is just a mashup of its two key parts, a carbonyl group, which is a carbon double bonded to an oxygen, and a hydroxyl group, an oxygen bonded to a hydrogen. You stick them both on the same carbon atom, and bam, you've got a carboxyl group.
Now, let's meet a couple members of the family. What's so cool is that their common names are basically little origin stories. Acetic acid, well, that comes from the Latin word for vinegar. Butyric acid comes from the Latin word for butter, and my personal favorite
Has to be formic acid. The name literally comes from formica, which is Latin for ant. You know that sharp little sting you get from an ant bite? Yeah, that's the ant injecting this exact carboxylic acid. It's just amazing how nature puts these molecules to work.
So we know what they look like, but where do they come from? Let's take a look at a common origin story for how these molecules get made in the first place.
Okay, so one of the most common ways to make them in the lab is through a process called oxidation. You start with something called a primary alcohol. Then you bring in a chemical heavyweight, a strong oxidizing agent, like potassium permanganate. This stuff basically encourages the alcohol to react, and when it does, it gets oxidized, and voila, it transforms into our carboxylic acid. It's a really fundamental, kind of elegant reaction.
Now, we've seen how they can be made, but it's that very process that gives them their special structure. And that structure is what defines their whole personality. It's a trait so important, it's right there in their name, acid.
So what does it mean to be an acid? Well, in the world of chemistry, an acid is basically a proton donor. It's a molecule that's willing to give away a hydrogen ion. That ability to let go of a proton is really the source of all their acidic powers. But wait a second. You might be thinking, hey, alcohols also have that OH group, so they can donate a proton too, right? And you'd be absolutely right. But here's the thing. Carboxylic acids are thousands, sometimes millions of times more acidic. So what's their secret weapon?
The answer is this incredible concept called resonance stabilization. See, when the acid gives away its proton, what's left behind has a negative charge. Now, in an alcohol, that charge is just stuck on a single oxygen atom. But in a carboxylic acid, oh no, that negative charge isn't stuck at all. It gets to spread out, shared equally between both of the oxygen atoms.
Think of it like this. Trying to carry a really heavy box by yourself is tough, right? But if you have a friend to help you share the load, it's way easier. That's exactly what's happening here. By sharing that negative charge, the molecule becomes incredibly stable. And here's the golden rule in chemistry. Stability is everything. If the molecule is more stable after it donates the proton, it's going to be much more willing to donate it in the first place. That's the key.
And this chart, wow, it just lays it all out. We measure acidity with something called pKa, and all you need to remember is, the lower the number, the stronger the acid. So look at ethanol, a typical alcohol. It's way up there at around 16. But acetic acid, the stuff in vinegar, it's all the way down at about 4.76. That is a massive difference, and it's all thanks to resonance.
All right, so we know who they are, we know their personality. Now let's talk about their superpower. And that's their incredible ability to transform into all sorts of other useful things. This is where they go from just being simple assets to being the building blocks of our entire modern world.
Let's start with one of their coolest tricks, making things that smell amazing. It's a reaction called esterification, and it's responsible for a lot of the pleasant smells and flavors we know and love.
So how do you make one? Well, you take a carboxylic acid and you introduce it to an alcohol. With a little push from an acid catalyst, a water molecule gets kicked out of the structure, and the two pieces that are left behind get stitched together to form a brand new molecule, an ester.
So why should we care? Because esters are everywhere. They're the molecules that give so many fruits their unique smells, like bananas or pineapples. They're used all the time as flavoring agents in food, they're crucial for the perfume industry, and they even make great solvents.
But making things smell nice, that's just the beginning. Carboxylic acids are true master builders. They're the starting point for a huge range of other critical compounds that really form the backbone of modern life. Remember the nylon from our opening question? Well, it's a polymer made from a special dicarboxylic acid, one with a carboxyl group at both ends. This makes it the perfect little connector piece to build long, strong chains. The soaps and detergents we use get their cleaning power from long-chain fatty acids. And that sodium benzoate you see on a food label? That's a salt made from a carboxylic acid, and it's in there working to keep your food from spoiling.
So when you really think about it, from the sting of an ant to the fabric in your clothes, this one humble little chemical group, the carboxyl group, is a fundamental building block of our world. It really makes you wonder, right? What other amazing chemical secrets are out there, hiding in plain sight, just waiting to be discovered?